Thank you, and I am very happy to be here to discuss about consciousness, because during a long time, as we say already this morning, consciousness was not at all a question that we wanted to raise in infants. So I want to start with this movie, because I am a pediatrician, and you see it's in the 80s, and when I saw these two movies at that time, if I am able to start the second one. Yes, I was very intrigued, very puzzled. And you see that they are neonates. And when you support their neck and avoid the subcortical reflexes, they can have this type of behavior in which you have the impression that indeed they have voluntary movement, they are clumsy, but they are able to direct their attention to the object and to explore this object. And at that time, we had this notion that the brain was very immature. We got a little bit of that this morning, and that indeed everything is still not finished in neonates. And we had the first brain imaging data showing, for example, that the metabolism in neonate is only around the basal ganglia, so they were not at all cortical. And when you look after that to what brain imaging brought to us, you see that indeed we saw with this type of structural brain imaging that the human brain at start is very immature, with in particular the high level regions that are very, very blue in this type of images, meaning that they are very immature. But what we have seen already this morning is that in fact this is a very old vision of infant development, and that this immature brain does not mean that it is an unstructured brain, and that we have a very now important evidence that the brain is structured very early on, and we see this morning very beautiful data from the DHCP Connectome project, and that also the high-level regions are functional. And we also see and some other speakers this morning that under the right condition, preverbal infants not only show complex cognitive abilities, but they show complex cognitive abilities that may not be only reflexive or statistical or whatever, but may need explicit representation, and that much earlier than expected. So I want to show some evidence on that, and after that, ask directly, do we have some evidence that infants are conscious? And when I say conscious here, I am really in the line of this movie that we saw, that is the fact that you have an inner drive in the baby that make him explore the world. So maybe it's attention, not maybe what you call consciousness here, but it's what I am interested in, is to understand how a human baby can have information about the outside world and learn about this world. And so we will look mainly around this age, so going from 3-6 months to term and to preterm infants. Okay, so first evidence that immature does not mean non-functional. We have many fMRI studies in which we have shown that, so it's not in that case resting state, it's really activation studies in which we show, for example, that when a baby is awake and is listening to his native language, you have nice activity in the right frontal areas that you do not see when they are asleep. When you present two sentences which are the same at a few seconds of distance, you see that for the second presentation of the sentence, you got activity in the left frontal brain area, which we related to some working memory. In that sense that we do not say that the baby remember exactly what is said, but that the melody, and we know that they are sensitive to the melody of speech, that they recognize that the same melody has been repeated. And when they are listening to their mother voice, you see that you got activation in the medial prefrontal cortex, which is related to self and familiarity in adults. And when they are listening to an unknown voice, which is in fact the mother of the previous baby, so it's still a mother, but not their mother, you see now that you have activity, more activity for this unknown voice relatively to the mother voice in the orbitofrontal cortex and in the amygdala. So something more related to assignment of value. So you see that not only, so it's 3 months old in all these studies, that not only they have frontal activity, but also that it's not the general frontal, it depends on the task, and that you can elicit activity depending on what the baby is doing during that task. You have now very nice evidence also, like we saw this morning, that the functional connectivity, so at rest, is similar in and network selective at different, in neonates that it is later. So it's what Professor Nakris showed this morning. So I will not say it again, but you see that when you look in neonates, children or adults, and when you put a seed in different part of the brain, you got the same selectivity in at this 3 age, even if in neonates the selectivity is less important, but as we have said, they are asleep, while at the other age they are awake. So it's difficult to make a point about the strength of this response. And the last one, I wanted to show you the movie, but it's not working, so I just show you the graph. We tested the 6-month-old preterm babies, so there we are at really at 30 weeks of gestation. The majority of the neurons are still migrating. They are in the what we call the subplate. They are not in place in the cortex. In fact, there are more neurons in the subplate than in the cortex, and we make them listen to syllables, so ba, 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 for example, or there was a change of syllable, ba, 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 ga, so it's what is in red, and from time to time a change of voice, so ba, 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 ah, so male to female, and it's the green line. The blue line. And you see here the response to this sequence of syllables, and you see that you have 2 curves each time for the 6 oldest and the 6 youngest, and you see it's always very small group, but they are very, in fact, the same, and showing that indeed it's present from 29 weeks of gestation. And you see first that you have a big response for the red curve, which is a change of phonemes. We are very surprised by that because it's ba and ga. And so the difference between ba and ga is 40 milliseconds in our stimuli. So something very, very rapid, and still they were able to discriminate the 2 syllables. In fact, we didn't get many results for the voice. That was also surprising because the voice is supported by the whole syllable. So we were really expecting that the male to female, they will discriminate. But in fact, you see here, you have not many response to a change of voice relatively to the standard situation. In fact, we get a response for the voice only on the right side, in the right frontal area, in which we get, in fact, a response for both type of change, while on the other side, on the left, you have a response only for the change of phonemes. So again, you see that you have a response which is going until the frontal areas, and that you have not, it's not everything for everything. So when you have a change of voice, it's not processed as the same as a change of phoneme, and that indeed you have in humans, and we did the same experiment in rats. In rats, we get a big response to a change of voice and almost nothing for the change of phoneme. So it's related to the fact that we are humans and that maybe we have a specific network to process speech because it's so important for us to communicate. But what I wanted to show with these three slides is that indeed the system is organized very early on, and it's what we saw also this morning. And it's not only resting state; it's also activation. That you have activity until these very high level areas. Another point I want to make also is that, I say immature does not mean confused, is that in fact, thanks to a new type of analysis that we can do now, like for example, decoding, we can see that indeed the mental representations that are present very early on are very specific and very I can say very specific. Okay, so for example, here we look at with Julia Gennari about whether babies have responses to number. And so, as you know, when you present sequence of number, so we choose auditory sequences because we can test them asleep very easily and during a long time. You can either present 4 versus 12, but 12 beeps will take you more time than 4 beeps, so you want to equalize the duration, but in that case, you have, like here, you are rhythmically more faster. So it means that the problem of number is that you have always a confusion between duration and between rhythm, because either you equalize one or the other. The advantage of decoding is that you can, for example, decode 4 versus 12 here in these 2 sequences, in this type of sequences in which the duration is similar, and generalize to situation in which now the duration is different and the rhythm is similar. And you can see that when you do that, you are able to decode 4 versus 12 in babies at the end of the sequence. And that is not the same that when you try to decode the rhythm, which is in purple here, or the duration, which is green. And you see that you have a very specific representation of number, which is really independent of the representation of rhythm and of duration. What is also interesting is that, relatively to all the oddball paradigm and so on, is that you can take the decoders that you have trained during the sequence, and in the same babies, because they were nice, we can test them awake and present to them now 4 versus 12 object. So they were awake, so it was before or after the auditory sequence, but you can use the decoders that you have trained on the auditory and see what happens on the visual, and you see that you are able to decode also the visual number. So it means that here, all the electrodes. So we were not able to be more specific. But still, it means that we have now a representation which is that we can show is automatic, a model independent of sequential versus simultaneous representation, and that it means that what I wanted to show with that is that the internal world of the baby is very rich, but it doesn't need to be conscious for that. We did that asleep, and it was working, and it has other representation for pitch, it has other representation for phonemes, and I can think that there is many, and there was some decoding also of visual images. So all these stimuli have already their network, and they are already processed until some very high, complex representation. So the question now is, okay, you have this complex world. You can see that all this representation can be computed one after the other until maybe high-level regions. So the question now is that, and what I am interested in, I don't know if it's consciousness, is that, okay, do you have an inner drive? Is the baby able to say, I want to look at that, I want to be interested of that, and I want to learn about this object. And I think it's important in our species because we know that we are giving information. We know that we are orienting the baby toward learning about that or that aspect just by naming, just using language. But if you want to say to the baby that that is a grape, you need two things. You need to have a top-down control of the object of attention for the baby. You have shared attention between the adults of the baby. And you need that for the baby to know that he will receive information from the adults. And you need at the end a symbolic system to communicate the concept between the two brains. But I think that it's something very specific in the human species, and it's why I am interested in consciousness, is to know how the baby knows that he will receive information and that it will help him to understand the world. And just to give you example of this type of learning and how early we thought it was that babies were learning words in the second year of life. But in fact, there is very nice studies, but that shows that at least they have the capacity to do it. And one of the one I like the most is by Sandy Waxman and her team, in which she showed to 3-month-old and 4-month-old babies images like that, and each time you got this type of images, you have the look at the toma, do you see the toma, and so on and so on, and suddenly the baby sees these two animals, and what you are measuring is whether the baby orients to the fish in that case. Because if he has constructed the dinosaur category, the fish is new. But we say, okay, but 3-month-old, what do they know about dinosaurs? That's completely a crazy idea. But if you look at all these images, you see that in fact they share some shapes. That is, you have legs, you have neck, you have all these parts protruding from the body, which is not the case for the fish. So there is some commonality between all these images, and the fact that you name helps the baby to find that there is something common because they share the same name, and that could be opposed to this fish. And how do we know that? It's because when you name, when you say toma, you have the orient to the fish at 4 months and 6 months, while when you present backward speech or tones, they do not do it. So it's really because, and there is several other experiments showing that it's really because it's named that they are able to construct the category of the dinosaur. Another experiment we did, and just to show you also how complex these babies can be, it's an experiment in 5-month-old using EEG, and we wanted to know whether they can learn a rule like ABA. That is, and to do that, we present to them words like tu-la-tu, so the first and the last syllables of the word are repeated, and each time they hear the word of that type, they saw a fish 1 second later. And we had a second rule, which was mimiron. In that case, the same, the syllables is repeated immediately, and now they see the lions. And we were changing always the syllables, so no word was repeated. So they have to extract the rule, and not only to learn one word and one image. It was a rule toward the image. So after a few trials to learn, we start to present incongruent situation in which for example, you had, gougouffé, and you get the fish instead of the lion. And we introduced a third rule because we wanted to know whether they really learn the rule and not just the repetition. And now you have word like ABB, so the repetition is at the end, and they are 50% of the time the lion or the fish, so they cannot learn. Okay, so what happens? We are looking at EEG. What you expect is when you have a mismatch between what they have learned and what we present to them, they should have a surprise effect, and it's what we get. So if you look at the response after the image, you see that in fact the incongruent situation, the incongruent pair, you have a decrease of the response relatively to the two other situations. So they are surprised in the sense, and we got it several times in this type of paradigm, is that when you are surprised, they are like inhibited, no response relatively to the situation in which they got the correct pair, or they have not learned anything about the neutral situation. Now, if we go back, I don't know, I have not said to you, but the image was projected on a flickering background. And we use that now to focus, to follow their attention. Because if they focus on the image, they are less exposed to the background flickering, and so the power to the congruent decrease. While when they are surprised, they have this opening of their attention, and you have an increase in the power of the background. So we got this effect showing that they were really priming the correct image. And now we can look what happens before. So between the noun and the image. And in that case, the only situation for which they cannot predict something is the third rule that we gave, because In that case, they were waiting either for one or the other. And you see that you have a big difference between this green condition, so the condition for which they were not predicting anything, and the two other conditions. So what you see here is really a complex chain of operation in a baby's brain, in a preverbal infant brain, because they are 5 months old. So they have to detect an abstract structure. They have to associate this structure to an arbitrary image. And we can see that how they are doing that through the course of the ERP. We see that they have an expectation of the image with this CNV, focusing attention with the frequency tagging, and the surprise with a mismatch response when the expectation is not fulfilled. So you have really this impression that you are going through the time and see how they can do that. And so the hypothesis, and you will not be surprised if I put the global workspace. I have some relation with somebody behind this. I cannot say anything else, otherwise I will be... Okay, but still, I am not joking. I think that to do that, they need to be able to maintain a stable and explicit representation, and to really put together, for example, if we come back to the Thomas, this visual image and this auditory label. So they have to integrate that, and I think the only way to do that is in a global workspace, and to after that amplify the image and to learn this relation. So if I say that, I need now to show you that indeed we have some evidence for this global workspace, I will now go back to what Sid has shown this morning. So I want to show you 3 properties. So entrance is the global workspace is threshold and serial. So it leads to competition between stimuli. And so we will speak again about the attentional blink and or masking effect, and also that if you have the second aspect of this global workspace is not only the ignition and the entrance, is also that you have top-down amplification, and I want to show you that you have also top-down sensory amplification when you expect something. So already you have seen that this morning, so I will go fast. So what we are looking at is to use the fact that in adults, when they report that they have seen versus when they have not seen, you have this late effect, which is maybe not a P300, but you have a difference. And you contrast that with an early effect in which you are really in line with the stimulus. So you want to contrast 2 aspects in the brain, all what is in line with the stimulus, and you will variate the parametric property of the stimulus to see this relation between the stimulus and the brain response. And after that, you want to see whether you have a second type of response in which you are no more in line with the stimulus, but more in line with the response. Except that in babies, we do not have response. So we are just using the fact that in adults, if you had a response, you will have this type of response. So, and I will show you what seed experiments with Sophie on masking. And he has no time to show you the behavioral results, but I will show you now. So in 5 months old, so you see a mask, and after that they saw either a face or a control trial, and on the side, and after that mask. And what you are looking is whether the baby is looking. Normally, if he notices a face, he will orient to the face, and if he notices nothing, he will orient randomly to one or the other. So if you look at 5 months old, you see that at 500 and 100 milliseconds, they are random. So they do not know where is the face. While after that, they are not very good, but only significantly better than chance, and they orient to the face. While in 15 months old, you see now that they are much better. Already at 50 milliseconds, they see the face and orient more, significantly more to the face than to the scrambled face. And you have seen also that this morning, so it was a 15-month-old seed, and you see that indeed, and you have here the duration of the presentation of the face. You are going from the short here presentation to the long presentation, and you see this perfect linear relation between the duration of presentation of the stimulus, between the two masks, and the amplitude and duration of the P400. While when you arrive at the end of around 1 second, you have now this on and off response, with all the response below the threshold, which is here, 50 milliseconds. The 17, 33, and 50 are here, while all the others are on the other side. And for the 5 months, so now you have only one which is different, which is the 50 milliseconds. And but still, you have, it's less beautiful, but you still have this linear effect, and here the all and none effect. Okay, so it's I repeat what Sid said this morning. You have 2 stages observed in adult, and what we want to see is whether these 2 stages are also present in the baby, and it's what we have the impression to see in this mask experiment. And as also Sid said, it's much later. Why? Because the frontal are very immature. We saw that at first. They are not so it's not myelinated, so you need to transfer the information from the visual cortex until the frontal area, but you have no myelination, and still it's quite brain. And also you have all the synaptogenesis and so on is not done, so the frontal areas are very slow. They are functional, but very slow, is what we see here. So the second point is the attentional bottleneck. So you see this morning, Sid presented that. So, and he was saying that at 5 months, the attentional bottleneck is at 1 second too. And we did at the same time, the same experiment in EEG. And so we use the same idea. In fact, you have here teddy bear, which is changing at each time, at each trial, meaning that it will be novel for each trial, so the baby should orient. And after that, you have on the side either normal face or scramble face. And after that, a T3 to be sure that the baby is doing something, that because if he does not see he will have nothing to do. And so we vary the SOA between the presentation of the teddy bear and the presentation on the side. And we had also trials in which there was no face at all. So you have Q and no Q trials. And we were measuring several stuff, and we had several indexes, and it's very interesting because we have behavioral and EEG responses. So for example, you have the teddy bear, suddenly you have a face, you see the face, you will orient to the face normally. And you see they are not very good, but at 1,200, so again, a very long SOA, they orient a bit more to the face than to the scramble or to nothing. And when you look at the pupil size, you see that there is nothing. So in green, you have I don't remember, the no Q is in blue and the Q trials is in green. And so you see that you have no difference at 400 milliseconds, 800 milliseconds, but you got a difference for 1,200. So we replicate what Sid found, although they are 3 months old here. And when you look at the neural entrainment, so the fact that the images were presented over a flickering background, no effect at 400, 800, and we got an effect only at 1 second too. So again, it means that because they are so slow, it's so slow to enter in their frontal area or frontoparietal system, it's also they are slow. So when they have something, it's for them also difficult to disengage and to come back. So they need 1 second too to be able to between the 2 images to be able to notice the second one. But what is interesting here is that we were able to, because you can say, okay, just because, and we discussed that a little bit in the last presentation this morning, it's because you have a low level effects and that in fact when you are going fast, their visual system is not very good. And so they are not able to see the two stimuli, so you are not sure whether it's a low-level problem or a high-level problem. So here we were able to separate, in fact, two types of trials at a very high level of visibility. So at 1,000, when you have this long SOA, 1 second 2, we use a new way of doing stuff, is to look at how close each trial come to an attractor, the attractor being the topography of this big visual response, the P400. So for each trial, we can see, okay, you come very fast, close to this topography, or you come a little bit slower. We are not sure that it will work, but we just take the median, and we separate trials which were fast and trials which were slow to come close to this topography. And as you can see here, the blue and the red line is not surprising, because by definition, we choose those who were separated. But what is interesting is that when you take the late P400, you see before that you have this negativity that you do not see at all in the fast response. And this negativity is usually the sign that you are processing a phase in babies. It's not the equivalent of the N150, 70 in adults. And so you get it here, and not when you go fast to the P400, showing that maybe they were more engaged with the teddy bear images. What is interesting is that you can look backward to what happens before, and you look at the pupil size before the arrival, the onset of the teddy bear, and you see that you have a difference for the two types of trials. So it means the baby was not in the same stage, so maybe it explains why he was more or less engaged with the teddy bear. So already it's not trivial that we found that. But after that, you can look what happens for the face that we present on the flickering background. So if you look at the blue line, for example, here, so you are deeply engaged with the teddy bear, and so you have no saccade to T2. You have a reflexive saccade because you have no difference to the orientation to the face, or when there is a face or no face. When you have no cue, or when you have this face, scrambled face, you see you have no difference between the two types of the number of saccades. When now you have had this shallow attention to T1, you see that you have much more orientation to the face, to the side than when you have no T2. And when you compare the two situations, you have a much more correct saccade in the case here. So it means that you have this effect, that you see that even when it was visible, because you were engaged to the T1, you are blocked to see T2. And you have the same effect with the neural entrainment. So here, when they were attentive to the teddy bear, you have no difference between the two Q and no Q trials on the flickering background. And here, when they were not attentive to T1, they were attracted by the stimulus on the side, and you have a difference between the two types of trials. So here you see that really it's an attentional effect. It's not a low-level effect, and it's really show that you can only have one element at a time in this attentional window, and that is a signature of this global workspace. But again, you see, it's very slow. We are 1 second 2. So in adults, it will be evident that there is something on the side. And now my third evidence about the top-down activities coming from the team of Ghislaine. I like it a lot because I think it's so simple. They just record with near-infrared spectroscopy the posterior areas or the temporal areas, and they just presented a beep followed by a smiley. So you have beep, smiley, beep, smiley, beep, smiley, beep, smiley, and then the beep with no smiley. What happens? And here you can record directly the activity in the visual cortex, and you see here the response when you have the beep and the smiley, so blue for the temporal areas, red for the visual area. But here, normally you have only the beep, no smiley, no visual images, and still you have as strong activity in the visual area. In fact, the babies were waiting for the smiley. And it's not because they are synesthetes. There was this old idea that babies were synesthetes, that as soon as you have a visual images, you have auditory activation and reciprocally. But here you see in two of the group in which they got only the beep or only the smiley, and you have no activity in the oral cortex. So it means that here it's really because they were expecting and pre-activating their visual cortex. Okay, so I think that really I have no doubt that perceptual awareness is present in the second trimester with all this evidence about competition, serial bottleneck for successive, even top-down expectations that we have seen here with the Ghislaine experiment, but also that we got with the CNV when I was showing you the ERP evidence for that, and that it's a much slower process than in adults. The problem now is before, because intuitively, I have no doubt, and we discussed that this morning, but how do we prove it? And we have a problem because their visual system is very immature. They are not very attentive during a long time. So they may be conscious, but it will be difficult to show. And often people have used auditory responses, and maybe we will have more on that this afternoon. And one of these a paradigm that we can use is what they have called the local global paradigm, in which you present, for example, a series of beep, 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 and suddenly you have beep, 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 boop. So you are surprised because you have a change, but also because it violates the regularity of the block. Now, if you have beep, 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 boop, beep, 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 boop, beep, 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 boop, and suddenly beep, 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 you have no local violation because it's a strict repetition, but you violate the rule of the sequence, okay? And with that, they have shown in adults that, again, you have this two-stage that we described before with an auditory system that respond on and automatically, if you are asleep, if you are in comatose, in vegetative state, as soon as you have a change, so as soon as you have beep, 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 boop, you answer. But to detect the change in the sequence, and in particular, to detect that beep, 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 beep here is a violation. I think this condition is a crucial condition, that beep, 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 that a strict repetition is a violation of a higher rule. So they show that you got that in conscious patient, in adults, and so on. And it could be a signature of consciousness. I must say that I have a reserve on this paradigm, but it's true that it's the only one that we can use very easily in young babies. So we have tested it in 3-month-old, and we get mismatch response as soon as you have a violation. So as soon as you have a BB boop, which is not surprising, even I show you at 6 months of gestation, you got this type of response. So there is no problem to get this type of things, but also, as you can see here, you have a and here it was done by Julie Moser and David Pressel in Tübingen using this MEG system, and you see again that you get with the MEG this difference between XXX and XXY, so as soon as you have a change. What is interesting now is to look at the global deviance. So what happens now when you violate the rule of the sequence? So in babies, it's 3-month-old babies, it's a late response that we got also at the second. Again, it's very late, and you see especially that you have a difference when you have the strict repetition relatively, when it's a rule relatively to when it's not a rule. And in the MEG in neonates, you see that it was, it was that. And that is always a problem because you have a Y, a boop, which is very, if you have beep, 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 boop, just by statistical computation, you see that you have a big change because this big boop is very rare. So you have a big effect. And here you have nothing. But in this experiment, we can split the data as a function of the heart rate variability. And you see that when you have high heart rate variability, you see a response which is present for both rare element and not here. So we can say that maybe neonates are able to have this. Maybe it's a signature in neonates that they are conscious of the global response. Now they have gone on, and maybe we'll have more this afternoon. But in fetuses, in which you do the same experiment, and you see that at 28 weeks of gestation, this seems to have no difference between condition whatsoever, which annoy me because normally they should react at least at the Y change. And here you have no response to the local deviance, but response to the global deviance, which is very bizarre. It means that in that case, between 35 and 40 weeks of gestation, they are not responding to BBB boop, wherever is a boop, but they are responding when you say BBB boop, BBB boop, BBB boop, BBB beep. So you can wonder whether in that case, because we are in fetuses here, and we discussed also this morning that fetuses may be, how do you say, you have substances in the placenta to sedated. Thank you. They are sedated, so maybe they are for them words. So it's no more beep, separate events, but the word beep, 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 and the word beep, 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 boop. So now you have a difference because you change of words. Even when you have beep, 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 boop, beep, 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 boop, beep, 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 beep is a new word. And why we are saying that is that, in fact, I recovered this old paper in which you have anesthesia in macaque, and in which they get exactly the same thing when the macaque have been anesthetized with propofol. And propofol is a GABAergic antagonist, if I say correctly, while with ketamine, they do not get that at all. So it may be, and we know that the GABA system has a very bizarre function during development. It changed, it was excitatory, it became inhibitory. So there is, and so maybe it's some interesting fact to pursue, because you have exactly the same in this propofol anesthetized macaques than in this experiment between 35 and 40 weeks. I conclude, because I saw that I have So, as we said this morning, post-term infants have really the structural and functional architecture which support conscious perception in adults. So they can actively store content on which they can act. There is competition to access central workspace. But these processes are very slow, and even at the end of the first life, and it's possibly that in the first week of life, it may be during short period of vigilance. So it may be that it's not all the time, but they may have this short window in which they are online with the stimulus. In premature infant and fetuses, I must say that I don't know. We need to see more precisely, to have more experiment. We already say that this morning. And we also should compare fetuses and preterm, because this may be very different in both. We know that birth can provoke some changes in the also neurotransmitter and so on. So we need to do more experiment. My bet will be at 35 weeks of gestation, because we were speaking about thalamo-cortical connection, and with EEG we see a very big change with a signal that become more continuous around 35 weeks. Before we have this tracé alternant with very long period of nothing at all. even if it's maybe working under, but you have this high burst of activity and after that, nothing at all, high burst, nothing at all, and it becomes continuous around 35 weeks of gestation. So, but we have all of these elements to be put together to see better how it can emerge. Thank you very much.
Nice, thanks, Ned. That was a great talk. Thanks, Ghislaine. I have a quick question about the study in which you have the teddy bear in the center, and the idea is that it's taking some time to disengage, right? So that is taking some time probably to disengage from the teddy bear. And the question is, if you analyze throughout the block, probably they're getting more used to seeing the teddy bear, and therefore maybe they're attending less to that. Have you looked through the block to see if it's...
No, it's like you know, sometimes you are in after that, you say it's boring, and something for some reason, you have a one which is particularly attracting because it's changing it each time and you come back.
Oh, so the teddy bear is not always there, it's changing every time?
Yes.
Okay, I did not understand that.
It changes every time to grab the attention at each trial.
So it's a different object, a different animal, something. Yeah. Okay. I had not understood that, thanks.
Yes, thank you. Wonderful talk. So I want to connect the last paradigm, the auditory, or the question of inner drive. So what do you think the auditory paradigm shows about inner drive? Are they like...
it's not my favorite. I know they use it a lot in comatose patients and it has nice results, but I think that it's not so... it's not as pure as the other one, in which you need attention to orient to the visual images. Why here it's coming, and I don't know what you have no. I mean, it does not mean that there is no inner drive for an auditory stimulus, but I have no way of controlling whether they are attentive or not, whether they are doing something or not. It could be totally bottom up for me. And some of these results could totally be explained by statistical relation between the syllables, between the tones in the sequence, and that if you have a buffer which is long enough, it's sufficient to have the global effect. So we disagree with some people in my family on this topic. I think it's not the perfect paradigm to see what I want to see, for example, in terms of inner drive and so on, and how they can select something. I think due to experimental reasons, it's much easier to do it with visual stimuli.
Yeah, just a follow-up. So you think the statistical one they could do unconsciously?
Yes.
And the inner drive would be correlated to some conscious processing?
I think you can resolve that without being conscious.
Okay.
But you can be conscious and take advantage of that. I mean, that's the problem, is that if you are conscious, even if you have statistical process behind, you can use them to discover something in your world. But if you are unconscious, it could work. We can do it in asleep babies and see what happens. I think it's not enough. In the comatose patient, when they say it predict, they ask the adult to count and to, so you have this, in fact, it's not directly the paradigm, it's because you ask the patient to do something. So, but auditory is much easier in younger babies.
So I'm going to call on myself. We have very good reason to believe that we can be conscious of more than one thing at a time. So, for example, the McGurk effect shows an interference between the visual and auditory impression. So, that makes it...
I disagree. The McGurk effect is not a good example. You can in the superior temporal sulcus, for example, a visual and auditory integration, which are totally unconscious. And you do not need, even if you have two, it's not two arbitrary signs that you put together.
Okay, so maybe that isn't the best example, but we have plenty of examples right now of being able to see something and hear something at the same time. Intuitively,
it's why I say I am not interested in consciousness. I want to understand.
Oh no! But,
I want to understand how baby learn and
Okay.
so how it is in the.
this is leading to a question.
Yes.
Which is, if we can be conscious of more than one thing at a time, then the global workspace theory has to allow for more than one thing being conscious at a time, in which case your reasoning wouldn't work about the attentional blink, because your reasoning was, we need the global workspace to explain how we miss T2 when we are attending to T1. And so I understood your argument. It's only the global workspace can explain this, because we're conscious of T1, so we can't at the same time be conscious of T2. But if the global workspace has to allow that we can be conscious of more than one thing at a time, your explanation doesn't work.
I will let the people of the global workspace explain this without. I go in the reverse direction. I say, okay, we have phenomena in which you are conscious only of one thing at a time, because you cannot see a second. You have attentional blink, and that I explained, because you need to your attention. So I know that I am speaking more on attention than consciousness.
Okay.
But I think that it's in babies, it would be impossible to separate attention and consciousness.
Fair enough.
And I think that in that case, and I think it's important for baby to learn to have this system which is stable, explicit, and which can because if they are only submitted to a very bottom-up and non-conscious stimuli, it will disappear. While they need to keep that during several seconds to work on it. And it's why what is interesting for me.
Thank you so much. Thank you so much, really beautiful talk. I want to go back to Claudia's question about the inner drive and look at different senses, not just vision. So for instance, like, you cannot choose of being hungry. At a certain point, you are hungry, right? So you have the drive to go for food. But wouldn't it be in your theory that I'm conscious only if I have the drive independently of being hungry, of going out there in the world? So the idea is like, where exactly the inner drive kicks in and at which senses? Because it's easy to do it with vision, engaging with the real world, but how about the senses that are coming from inside over which we don't really have control? I mean, I don't have the drive to have my heart beating or being hungry, but I need to do it to stay alive. So it's like, where do you put the distinction between the senses that, so I don't get the inner drive thing.
For me, the inner drive, again, I am a pediatrician. Because I am always a little bit, anxious when I'm speaking about in front of philosophers and so on, because I am not at all at this level of theory. For me, it's just, okay, I am a baby, I am hungry, as you said, and I cannot move, but I can choose whether I want this or this. That is, for me, the inner drive is not really the basic reflexes and instinct and whatever. It's the fact that you choose at some point to act or not to act, to choose that or not to choose that. And I think that it's already present in babies. They are not little machines that are totally bottom up and that you can put they have already a personality. They are already a person that can choose. Who can choose? It's not that. Sorry, again for my English. And that only that I want to show. So maybe I do not have the right terms, but I think that we have now the way by experimental design, by the way that brain imaging bring to us to look at that. After that, if it's consciousness, attention, it's not really my topic. I want just to know what they are able to do, what they think. So I have, I say, I use some postdoc because I have an ERC, which is called baby thought. And I want, the goal is to be able to decode what they are thinking at each time point and to see what content they have. what is called inner drive. What is the content of their soul? Are they just nothing, a zombie, or are they already thinking about what is happening?
We have time for one more question.
Thank you. It was a really interesting talk. I just want to sort of follow up on that sort of idea of leave consciousness aside, but the purpose for the baby and for all of us is to survive.
No. It's to understand. It's to understand. I mean, I think to survive is a basic. But I think that these babies, they do not want, when they come to the lab, they don't want to survive.
No, I mean, okay. So,
survive is the basic that we should provide to them, but it's not, because otherwise we are just like the other animals.
No. Okay, so the reason for asking this was your last point. You made a really interesting speculation at 35 weeks.
Yeah, it's completely speculation.
Yeah, but I like that speculation. So because around 35 weeks, without neonatology, babies can survive. That's around the time babies can start delivering and survive in the outside world. And so at that point, the babies need to survive in a complex world. And I don't think they can do that just through reflexes and instincts. So they are highly intelligent little people with personalities, but with some basic sort of, they haven't got the same sort of necessarily higher cognitive processing that you'd expect a toddler, you'd expect a child to have, but they have some degree of processing at term in order to get what they need, which is food and warmth. And it's not really a question, but it's just an observation on that comment, but one wouldn't necessarily expect the complexity before 35 weeks because evolutionary, until very recently, those children wouldn't survive.
I think that they won't survive. No, it's the problem of the parents. I think we completely changed the relation between the adults and the offspring in humans. It's a problem of the parents to make the baby survive. The problem of the baby is to understand. Because we are a cognitive species and we need what makes our survival is really the fact that we can transfer information and that we can learn from the others to build new information. I think we are a parasite of this. And so I think that they are driven not at all. I completely, I have not taken any Gopnik substance before, but I think that it's really a different push for babies and for other animals. Maybe it's a difference. It's why we are here and not a chimpanzee here. But turns out that the survival is really given by the parents. It's a goal of the parents.
Turns out we can go till 5 after 3, so we do have time for 1 or 2 more questions.
I kind of just had a follow-up on the last discussion, which is, I mean, even if it is our task to understand in addition to survive, unlike animals, I mean, the ways in which our cognitive functions manifest and the time at which they manifest would still be largely determined by what is necessary for survival. So, I mean, maybe this is also more of an observation than a question, but I guess I think I'm not fully understanding your response.
About?
In response, so I apologize. Yeah.
You do not understand my response. Or you do not understand this question. What's my question?
The parents interaction with maybe it's like a terrorist. They look very cute. They need food. They need water, and they evolved to ensure that parents will do that. For survival.
Yes.
So then the drive is to be cute.
Yes. But all the young are doing that for their parents. I mean, in the primates at least.
And you can't communicate with parents through reflexes. That's why it's a complex interaction at the moment. But I do wonder whether it drops off in below sort of 35 weeks. Just looking at an evolutionary perspective, until
Okay, I think you've asked the question. And, Ghislaine?
No, but I think that evolution perspective, you are nice when you say that, because how can we answer to evolution perspective? What is important in evolution? I mean, I don't know. I mean, you are responding for Homo sapiens with data in Homo sapiens in urbanized to explain what happened 200,000 years ago. I have no idea of that. I mean, we can speculate and speculate and speculate, but and I think that what we have to understand is why we are humans are so cognitive in some way, and why we are using language, and why we are transmitting information, and that we are doing very early on. We thought before that it was after 2 or 3 years of age. But what we see now is that if you put the baby in some situation, they know that they will receive information. So there is some experiment showing that, for example, if you are speaking and after that turning to the side, the baby will look to the side at 3 months. While if you are doing some noise and looking to the side, he's not looking to the side. So it means that he knows already that speech is conveying information, which is not really, which is quite extraordinary. So it means that something is built, and that what we are doing is trying to understand. I think it's more important to understand that to try to understand why we are why we survive. We survive apparently because we are here. So, I mean, I am sorry not to be very excited by higher philosophical discussion, but I think that our problem is more to see why and how we can help babies now in our time to learn. And because now what parents are doing is they are on their phones, so they are no more giving any information to the baby. And I think that is totally, and they speak about screen, but they say do not put the baby in front of the screen. So it's not my problem. My problem is the parents are in front of the screen and they are no more exchanging with the babies. And we know that is crucial. And that we should say, and I am more interested by that, sorry.
On that note, I think it's time to thank Ghislaine.